Hi, Adrienne. First of all, don't apologize. I'm more than happy to go through these problems with you. I totally understand that having an online class, especially statistics, not having it face to face and being able to ask questions can be really difficult. So this is good that you sent the Ask My Instructor. So first of all, in order for you to get full credit on this problem, you'll want to go ahead and once we finish this one, click down the bottom, click similar question, and then you'll be able to try this whole thing over again and get it perfectly right. So first of all, in letter A, the reason that this is marking you incorrect is because initially it says that the histogram for the time spent eating and drinking is skewed right. So considering it's skewed right, it cannot be considered normally distributed. Now, in order to be able to go ahead and use a normal distribution to analyze it, what we do is we increase the sample size. So here how it says, since the distribution of time spent eating and drinking each day is not normally distributed, that's what the skewed right. The sample must be large enough so that the distribution of the sample mean will be approximately normal. So you want to, again, increase that sample size, and then you can possibly go ahead and use the normal distribution to analyze it. Okay, so in regards to your confidence intervals, this can be done all with StatCrunch. So I know if you go into the text, it shows you all the crazy formulas and whatnot, but again, this is applied statistics. So we want to go ahead and be able to get the answer that we need as well as interpret it correctly. So we're looking for a 95% confidence interval for the mean amount of time Americans age 15 or older spend eating and drinking each day. Now they gave us a little bit of information in the top here. We know that the random sample has 1,003 people. We know that the mean was 1.57 hours and the standard deviation was 0.54. So what we're going to do here is we're going to go to question help and you're going to click StatCrunch. And what we're going to do is we're going to go to stat, and then we want to go ahead and do a analyzation or analyze the mean here. We're going to do a confidence interval for the mean. So because the sample size is reasonably large, we can go to Z-stats and do one sample with summary because we don't have the data. We have the mean, we have the standard deviation, we have the sample size. So here, I have that I have my sample mean is 1.57 hours, so I'll type in 1.57. My standard deviation is 0.54, so we'll type in 0.54. And my sample size was 1,003. Now what you're going to do is you want to perform a confidence interval, and I believe we wanted 95% confidence. So we have 95% confidence, and that's already there. And you click compute. So now what we're getting here, it's giving us the lower limit and the upper limit of the confidence interval that would have that 95% confidence. So I think over here they wanted you to round to, let's see, 3 decimal places. So first of all, we have to pick the correct interpretation. And again, that's what we'd like to do in applied statistics. So let's look at these. There is a 95% probability already. I'm thinking no. Right? So your confidence interval does not actually have anything to do with the probability that you get the true mean, but we would be 95% confident. So let's see here. The nutritionist is 95% confidence that the amount of time spent eating or drinking per day for any individual is between blank and blank, and I would say no here. They are using the correct 95% confident, but it would not be for an individual. Again, what we're doing is we're looking to capture the mean. We're not looking to capture somebody's individual time spent eating and drinking. So in letter C, the nutritionist is 95% confident that the mean amount of time spent eating or drinking per day is between blank and blank. So they're saying, we're 95% confident we've captured the true mean. So 95% of the time when you create one of these, you capture the true mean. So we want to round to 3 decimal places, so I'll click down here again. And I think it's going to be 1.537 and 1.603. So let's try that. 1.537 and 1.603. And let's check to see if that works. And we got it. Okay, so use those tips. Try to take a look at StatCrunch. Again, you might want to put these answers in for yourself so that you can then go ahead and check similar problem and then go through this and get the entire problem correct. Let me know if you have any more questions.